A mission that began decades ago is about to pay off. Push the F-150 to higher levels of performance and capability, but introduce new levels of efficiency by slashing weight. It meant a monumental investment in examining and testing the possibilities of new materials. The conclusion was inarguable.
Lightweighting translates into more capability, more efficiency.
We've looked at a number of different scenarios, and aluminum was clearly the best material to take significant weight out of the vehicle.
Long before we brought the engineers on, designing every component, we had already built prototypes. Nobody knew they were aluminum.
As early as 2009, Ford secretly delivered aluminum-bodied F-150 pickups into the field in a blind truck test.
It was at testing where we said, yeah, this is the right formula. This is it.
The alliance of two metals forged a machine more efficient and more capable than ever before.
From foil to soda cans to beer cans, trays, wires, cooking utensils, cutlery, and even alloys and many other items. Aluminium is indeed very versatile. However, I'll be looking at aluminium, the metal, as the future of automobile and aerospace. Before going on to the main topic, I would give a background on what aluminium actually is. Aluminium, coming from the Latin word alumen, is a greyish metal of atomic number 13. Sir Humphrey Davy discovered aluminium in 1807 in its raw form. However, in 1825, it was primarily extracted by Danish chemist Hans Christian Ørsted. Although aluminium is one of the most abundant metals in the Earth's crust, it is not freely found in nature. The properties of aluminium are that it is lightweight, it resists corrosion, which means it's non-toxic, and is a very good conductor of heat and electricity. Aluminium can be produced in two different ways: from scratch, or from other used aluminium products, or aluminium scrap. The primary production of aluminium is undergone by three steps: bauxite mining, alumina production, and electrolysis. The ore or the raw form of aluminium is known as bauxite. Bauxite, the main ore of aluminium, contains 30 to 50% of aluminium oxide, also known as alumina, or as a formula, Al2O. Whereas the rest contains a mixture of silica, titanium dioxide, and various iron oxides. On an average, for every 4 tons of bauxite, only 1 ton of aluminium is produced. However, across the world, approximately 160 tons of bauxite is being mined per annum. The deposits are located in subtropical countries such as Brazil, China, India, Venezuela, and many other countries. Before the main initiation in the production of aluminium, bauxite has to be converted into alumina. This occurs in alumina refineries through the use of the biochemical process. Bauxite is washed by hot sodium hydroxide, which forms sodium aluminate. Then the sodium aluminate gets filtered in the rotary sand trap. The decomposition of sodium aluminate occurs as it gets broken down into aluminum hydroxide and sodium hydroxide. The aluminium hydroxide is then heated to approximately 990 degrees Celsius, which forms aluminium oxide and releasing water vapor. Alumina is converted to aluminium by electrolysis, also known as the Hall-Héroult process, particularly for aluminium. Alumina is dissolved in molten cryolite with anodes and cathodes consisting of graphite, an isotope of carbon. At about 950 degrees Celsius, the oxygen ions surround themselves around the anodes, leading to carbon dioxide escaping the cell with the molten aluminium at the bottom of the cell and leaving the cell through the plug. Here I am at the Hindalco Industries plant in Taloja, 45 kilometers from Mumbai. Hindalco Industries is the world's largest aluminium rolling company with factories in more than 10 countries. The Taloja factory is one of the aluminium plants in India which produces aluminium rolled products. This determines the aluminium content in cars and planes. Moreover, the procedure to which the aluminium in the product is made. The Taloja plant caters to customers from over 50 countries with over a quarter of its production being exported. I was welcomed to the Taloja factory by Mr. B.J. Alexander, who is the Vice President and Works Manager of the Taloja factory, as well as Mr. Kishore Chavan, who is the Technical and Service Manager of Taloja. Here's my visit to Taloja.
Audio Jungle. Audio Jungle.
The used aluminium products and scrap come together and are remelted in the furnace, with the end product coming out as an ingot, which is the primary block of aluminium. The sides of the ingot are removed so that the aluminium does not have any impurities. Then, the ingot goes through the hot mill, where the phase is continued as a 600 mm ingot is flattened to about 10 mm of primary aluminium. Then in the cold mill, the process is repeated in 4 phases, where the 10 mm aluminium is further flattened to about 0.1 or half a millimeter. That aluminium is then taken into the coil, where the aluminium gets rolled, forming an FRP, also known as the flat roll product. The FRP is then converted into aluminium sheets, which are then stamped, cut, and fabricated into car and airplane panels.
Working in Jaguar Land Rover, we've got fantastic resources, fantastic engineering capabilities across our business. At the critical stage of this project, we had a third of all engineers in Jaguar Land Rover working on this brand new car, brand new platform. And being able to harness the skills and knowledge from key people and bring those things together really means we can move the Range Rover to be the pinnacle of refined capability. Jaguar Land Rover's aluminium manufacturing technology has enabled us to take 420 kilograms out of this car. So when we look at an existing Range Rover, a V8 diesel with an 8-speed that we launched at 11 model year, we have taken 420 kilograms out of that vehicle. We have downsized the engine from a V8 diesel to a V6 diesel with an 8-speed gearbox, and we've maintained the performance. So the 0 to 60 at this time is 7.9 seconds and the 322 V8 diesel is 7.8 seconds. But the CO2 has gone from 253 grams per kilometre down to 196 grams per kilometre.
One of the principal reasons we use aluminium is for lightweight. The intention is to save as much weight as possible on the body so we can get the secondary weight saves in the vehicle, and that adds to a big change in the performance of the vehicle, not only in the attributes such as ride and handling and dynamics, but also improves the fuel economy and, as importantly now, the CO2. There are a lot of urban myths about aluminium. However, the reality is aluminium absorbs more energy per kilogram than steel. So if you make something out of aluminium, not only do you make it light, but you actually make it strong. This car is very, very safe. The new roof crush test that's required in the US, which is 3 times gross vehicle weight, this car meets and exceeds by a significant amount that test. So aluminium is a good material of choice, not only for lightweight, but for great strength as well.
The all-new Range Rover to the Solihull plant has been a huge change, and it's not just a change to the physicals and the products and the plant, it's a big change culturally as well. It's the first vehicle of a brand new all-aluminium architecture, so there's a lot of pioneering in this vehicle. It's the first use in the world of aluminium on an SUV. The body side panel that makes up the new Range Rover is the single biggest one-piece aluminium body side in the world. And the new body shop we've just installed today is the biggest aluminium body shop in the world. So it represents a lot of pioneering and new activity for this plant. In terms of sustainability, our environmental impact, both in terms of the products and our manufacturing facilities, is extremely important to us. Less well known is the amount of effort we've put into designing the process and the facilities to be much more sustainable. So for example, an aluminium body shop where we have riveting as opposed to a steel body shop with welding, consumes far less energy than a welding body shop. So by definition, an all aluminium body shell with riveting is far more efficient, it's far cleaner. What we've done with the new Range Rover is we've retained everything that makes it so peerless, everything that the customers don't want us to undo that makes it so special, but we've added to that everything that makes it state-of-the-art from a technology point of view, and just what the Range Rover deserves.
The Ducker Worldwide has posted a staggering statistic that is predicting the future outcome of the role of aluminium in the automotive field over the last 5 decades. What the role of aluminium has just started out as the heat exchanger in 1975 has fluctuatingly had a role in more parts of an individual car, such as the alloy and even the cylinder heads and the engine blocks, an essential part of many automobiles. The main introduction of aluminium came after the 21st century, where the exteriors of the cars are being made ranging from the bumpers as protection to even the hoods and the doors. But the main attention is going to be in 2025, which is almost a decade from now, where the ABS, also known as the auto body sheet, will come into play.
Definitely. Aluminium, due to its properties of lightweight, high strength to weight ratio, and high thermal conductivity, has been a preferred material for engine body, engine parts, and castings for aluminium automobile. The latest entrant in is aluminium auto body sheet, which we call as ABS, and this will be a biggest game changer in the history of automotive industry. Last year,
The ABS has taken the automobile world by storm. John Miller and Mike Ramsey of the Wall Street Journal wrote an article regarding the ascending role of aluminium today and incisively put up a debatable headline which states whether all aluminium cars can drive the metal industry. And with the auto body sheets making headlines all around the world, then yes, the metal industry will live on aluminium's success and eventually become the future of automobile. Klaus Kleinfeld, the chief executive officer of the Aluminium Company of America, also known as Alcoa, made this comparison about the aluminium content in different parts of the exterior of an automobile. And the rapid hike of aluminium content is visible as the ABS revolves around the 2024 project.
last year in November, Ford F-150 launched a all aluminum bodied F-150 pickup truck, and it's doing wonders. Ford sells around 850,000 vehicles per year, and as aluminium goes into it, this will be the future of the industry. Plus, this has created a domino effect with other producers.
And this is where globalization has come into play. With the success of the Ford F-150 pickup truck that had an all-aluminium body, many automobile companies all around the world such as Jaguar and Land Rover of the United Kingdom, Audi, Mercedes, Porsche and BMW of Germany, and the General Motors of the United States have emulated Ford's approach to this prospect and have come up with their own upcoming projects.
GM is planning to introduce in Silverado, Chrysler in Dodge Ram, Toyota in Camry, in that is in US. Then When we go to Europe, Jaguar and Audi are major consumers of ABS, aluminum ABS. China, which is growing as a main hub for automotive industry, also will be a major consumer of aluminum ABS. Right now they are putting up plants to produce ABS, and they will be producing almost 30% of the world production of ABS. So they have a big plan going forward. So definitely aluminum has a big role to play in future of automobile industry. Let's see why people are shifting from steel or other metals to aluminum. One is lightweighting, and as per the current regulations which are coming up in US and Europe, in US they say CAFE standards, corporate average fuel economy. Currently it is at 36 mpg, miles per gallon, and they plan to bring it to 54.5 mpg. So this by 2025. So this has created a huge demand of aluminium in these vehicles because they have to reduce the fuel efficiency. Then again in Europe, the regulations say currently 130 grams per kilometer emissions should be in a car, and they have made a mandate to reduce it to 95 grams per kilometer. So the only way to reduce this is to use aluminium in these cars. The main, when we say aesthetics, aluminium is very malleable and it can be formed into different shapes. So it is a delight for the designers because it helps them, it gives them height, strength to weight ratio, and can be aerodynamically useful for them. The main parts which they are planning to substitute into aluminium is fenders, doors, hood, trunk.
Paul Williams of the CRU had talked about the CAFE standards through this evidence of how aluminium positively impacts the fuel efficiency of a car in terms of the miles per gallon as well as the carbon dioxide in grams per kilometer. However, aluminium does not only impact the automotive field.
In the aeroplane, the main fuselage, the structure, the wings, and even the wheels are of aluminium. Aesthetically, as well as to get the desired aerodynamics, the desired complex shapes can be easily made out of aluminium, and so these components are very key components in the airplane.
Already, many components of an airplane are made of aluminium, such as the fuselage stringers and frames, the wings, the seat tracks, the floor beams, and even the upper and lower wing skins. So you can see that there are almost 40 to 50% of the plane is made of aluminium. Today, many commercial airplanes from different parts of the world have used aluminium as it plays a massive factor, especially in terms of the plane being more lightweight. Also, many military planes and space companies want aluminium in their products due to its durability, lightweighting, and even its strength. Even though the future of aluminium in aerospace will not drastically hike up in comparison to the automotive field, I'm going to be looking at the sustainability of aluminium in aerospace.
The aerospace market is going to grow at a rate of 2 to 3% in the next decade. Boeing and Airbus, the major manufacturer of aircrafts, they produce 90% of the aircrafts with metals and not plastics. And as the industry develops lighter alloys, demand for aerospace aluminum will remain strong for the years to come. Looking into future, the aircraft of tomorrow may be a mix of aluminum and composite material, but still the single aisle planes will continue to score with aluminum because they rely upon thinner aluminum scales and the weight benefits of composites are negligible. So as per the industry experts, aluminum will be there for at least 10 to 15 years in aerospace unless some other metal is maybe innovated or something happens, but still, as we say, aluminum will stay for aircraft. When we see aerospace market, as by a few researchers, it's almost 2 to 3% growth rate for next decade. Boeing and Airbus, who manufacture major aircrafts, are still having aluminium as the main product.
Again, globalization plays another major role as many space and military flights have used aluminium in their planes and has been an existent presence since the mid 20th century. Therefore, this idea has been influenced as a change in the commercial airlines across the world, such as Boeing and Lockheed Martin of the United States, Airbus and Dassault Aviation of France, Bombardier of Canada, and Embraer of Brazil. Recently, Boeing has initially talked about the release of microlattice, which is considered to be the lightest metal ever. Well, even though microlattice is recent, it is not as proven as aluminium is today. Also, a major advantage for aluminium is the roaring success in the automotive field, which can lead to many companies, especially the commercial airline companies. Also, aerodynamically, aluminium is the ideal metal as engineers have often called aluminium a pain but a delight to work with. Microlattice is not the only competition as there are also composites being involved in planes and is also a very major competition to aluminium.
Aluminium current is normally 70 to 80% of the aircraft, and it has been the aircraft for years. Recently, new product was made like the 787, which had huge composites. That was the first trial in the market, and it has almost 50% of composites. Composites definitely has good advantages, but still, and there are few parts of the aircraft which has to be made by aluminum. Plus, the composites have two drawbacks. One is their safety is not good. So if you see safety of carbon composites, it's not as good as aluminum. Plus, when you compare weight-wise also, composites are the price-wise, composites are much more expensive. So, in a nutshell, aluminium will definitely be there, whichever alloy comes into it. But going forward, maybe it might reduce from 80 to maybe 60%, but it will be there in the